In this section we're going to solve some word problems or application problems, and to do so we're going to use our blueprint for problem solving. So if you haven't read this section of the book yet, you want to go and do that first to make sure you're familiar with the blueprint for problem solving. Let's look at our first problem. Okay, so step one, what we want to do is read and mentally list the items that are known and the items that are unknown. So we have a rectangle, so we know that. Twice as long as it is wide, so the length is twice the width, and the perimeter is 60 feet. So we just kind of mentally read back over the problem and do that. Step number two, we want to assign a variable to one of the unknown items. So let's let x equal the width. Then if x is the width and the length is twice the width, then we have this. Then 2x is equal to the length. So first we read over the problem and we just kind of mentally say what's known and what's unknown. Then step number two, we want to assign a variable to one of the unknown items and then see if we can write the other items in terms of that value of x, or that variable x. Step number three, we want to write an equation that describes the situation. So what we have for step three is that the perimeter, which is going to be twice the width plus twice the length, must be equal to 60. So here's our equation in step three. Twice the width plus twice the length, that's the perimeter, is equal to 60 because we know the perimeter is 60. The next step, we want to solve this equation. 2x plus 4x is 6x is equal to 60. Divide both sides by 6. X is equal to 10, and our dimensions are feet. So I found that the width is 10 feet, so the length is going to be twice that, or 20 feet. So I'll say that the length is 20 feet, and the width is 10 feet. Now I want to check my work. Let's just see what a rectangle will look like as far as its perimeter goes that has a length of 20 feet and a width of 10 feet. 2 times the width plus 2 times the length. Okay, 2 times 10 is 20, 2 times 20 is 40, 20 plus 40 is 60. So I see that I end up with 60 for the perimeter if the width is 10 feet and the length is 20 feet. And then I also notice that 20 is twice 10. So everything checks in the original words of the problem, so that's the solution to this application. Here's our next one. An accountant earns $3,440 per month after receiving a 5.5% raise. What was the accountant's monthly income before the raise? So step one, I read back through the problem and kind of mentally list what I'm given and what I'm asked for. I'm given that his current monthly salary is $3,440. He just got a 5.5% raise, and what I'm asked for is the accountant's monthly income before the raise. So I'm going to, for step two, let x equal salary, and by that I mean monthly salary, before his raise. Okay, so x is the salary before the raise. Now I want to write an equation that describes this situation. So the accountant's salary before the raise plus his raise, which is 5.5% of his original salary, so I'm going to say 0.055 when I change that to a decimal, times his original salary must be his new monthly salary, $3,440. To solve this equation now, I'll just add 1x and 0.055x. That gives me 1.055x is equal to 3,440. To solve this equation for x, I'll divide both sides by 1.055. I get x is 3,440 divided by 1.055. And that comes out to be equal to, when I do this on the calculator, I'm just going to write my dollar sign here, $3,260. And I'll just go to the nearest cent, 66 cents. So that's the accountant's monthly salary before his 5.5% raise. And I can check the work. I won't do it here because I'm kind of out of room. I could check the work by taking 5.5% of this. Okay, take 5.5% of this, add it onto this, and you'd see that I'd end up with $3,440. So this is how I solved that problem, and that's how I use those steps in the blueprint for problem solving. Here's our next one. A woman has a total of $9,000 to invest. She invests part of the money in an account that pays 8% per year, and the rest in an account that pays 9% per year. If the interest earned in the first year, see I made a little typo right here so I had to cross it out. The interest in the first year is $750. How much did she invest in each account? So I reread the problem and I kind of mentally list what I'm given. Total amount of money invested is $9,000. Part of it's at 8%, part's at 9%, and the total interest in the first year is $750. So you can see I have a little table here that I'm going to use to help me with this problem. And very similar to the tables that are used in the book to solve these problems, so you can read through the book and see some nice examples of this also. But I'm just going to say that the number of dollars invested at 8% is X. If that's true, then since there's $9,000 invested total, the rest is going to be invested at 9%. So that will be 9,000 minus X. The total amount has to come out to be 9,000, so if part of it's X, the rest of it's 9,000 minus X. Now the interest that's earned on the X dollars at 8% is 8% of X, so 0.08 times X. The interest that's earned on the 9,000 minus X dollars invested at 9% is 9% of that amount. So 0.09 times 9,000 minus X. Couldn't quite fit it in there. Now I'll write down my totals here. The total amount of money invested, this plus this, is 9,000, just like we thought. And then the total amount of interest earned on both accounts comes out to be $750. So I can write my equation this way. The amount of interest earned on the X dollars at 8% plus the amount of money earned on the 9,000 minus X dollars at 9% has to come out to be 750. So I'm just simply going to take 0.08X plus 0.09 times 9,000 minus X, and that has to add up to $750. So now, I'm not going to solve the rest of this equation. I'll leave that for you. But if I was going to, the next step would be to multiply both sides maybe by 100. So I'd have instead of 0.08, I'd have 8x. Instead of 0.09, I'd have 9 times this, and then 750 times 100 also. So we can continue. You can continue the problem on your own. That's just a quick look at solving some application problems using our blueprint for problem solving.